Good day everyone, I am Jimson G. Kusog of BSECE 3A. So for today, I will be discussing some of the topics in ECE 41 Communication for Lecture Module 8, which is Antenna Fundamentals. So in this performance task, I will be discussing some of my assigned topics based on my first letter of my first name, given name, and the last name. So for the topic that I will be discussing, so first we have here the slat antenna, next is the waveguide, and lastly the parabolic reflector antenna. So slat antenna. So it is a type of antenna with an opening cut of certain dimensions in a metallic conductor which is excited using two wires transmission line or coaxial cable. A rectangular slot is made on the conducting sheet. So the frequency ranges is around 300 megahertz to 300 gigahertz. So this antenna works at ultra high frequency and super high frequency ranges. So we have here the illustration of the slat antenna. So Babinet's principle. So according to this principle, the structure of the slat antenna and the half-wave dipole structure cut out from the conducting sheet are complementary to each other. So we have here the slat antenna, the conducting sheet. We have here the two-wire transmission line and the slat. So the region which is cut from the conducting sheet is the half-wave dipole that acts as the slat complementary antenna known as a complementary dipole antenna. So this one represent the slat and the complementary dipole antenna, which has the wavelength of lambda over 2. For the radiation pattern, we have here the figure, the side view, and the top view. So the radiation pattern of this slat is a omnidirectional. So just like a half-wave dipole antenna, so it shows the radiation patterns of slat antenna drawn in horizontal and vertical planes respectively. So for the impedance of the slat antenna, we have here the formula of the impedance Zs times Zd is equals to the No squared over 4, where the Zs is a terminal impedance of the slat, Zd is a terminal impedance of dipole, and the No in the intrinsic impedance of free space. So for the application of slat antenna, we have here the airplanes or aircrafts, and the ship antenna, which is the usually for radar navigational purposes. So it also uses some applications such as an array fed by a waveguide. So those are the application of slat antenna. Waveguide. So it is a form of radio frequency or the RF feeder or transmission line used at microwave frequencies. So the frequency range is around 1 gigahertz to 1000 gigahertz. So this is microwave frequency range. So it is used in variety application to carry radio frequency energy from one point to another. So we have here the illustration of waveguide. There are two types of waveguide feeder. So we have here the hollow feeder, and the other one is the circular feeder. So the rectangular feeder is the most commonly used form of waveguide and has rectangular cross section. So the dimension of the cross section sides determine the properties including the cutoff frequency. For the circular waveguide, as shown in the right, this is less common than rectangular waveguide. So they have many similarities in their basic approach, although signals often use a different mode of propagation. So the advantage and disadvantage of a waveguide feeder. So the advantage is that first, we have your very low loss, and also operate at very high frequency or in microwave frequency. And for the disadvantages, so we have here the expensive, not flexible, and special flanges adapter. For the application of waveguide, so we have here the first one is the optical communication system. So this one is used in optical communication. The second one is the photonic integrated circuit. It is used also in microwave ovens. And last is it is also used in broadcasting and radar installation. For the last topic, I will be discussing the parabolic reflector antenna. So often called as dish antenna. So the range of the frequency range is above 1 megahertz. So these are widely and commonly used for radio and wireless communication. This is the example of parabolic reflector antenna. Parabolic reflector basic. So we have here the main. So parabolic reflector basic. So we have here the two main elements. We have here the radiating system and the reflector. So for the radiating system, so the radiating element within the parabolic reflector antenna can take variety of forms. So in some antennas, it may be simple dipole. In other words, a horn. So for the reflector, so it is the distinctive part of the parabolic reflector antenna. So the parabolic shape is key to the operation of the RF antenna or the radio frequency antenna, because the path taken from the feed point at the focus to the reflector and then outwards are in parallel. We have here also the focus. So the focus or the focal point of the parabolic reflector is the point at which any incoming signals are concentrated. Also, we have here the vertex. So this is the innermost point at the center of the parabolic reflector. Also, we have here the focal length. It is the focal length of the parabolic antenna is the distance from its focus to its vertex. We have here the aperture. So the aperture of parabolic reflector is what may be termed its opening or the area which is covers. For a circular reflector, this is described by its diameter. So it can be likened to the aperture of an optical lens. And we have also the gain. So the gain of the parabolic reflector is one of the key parameters, and it depends on the number of factors including the diameter of the dish, wavelength, and the other factors. And also we have here the feed system. So the parabolic reflector or dish antenna can be fed in a variety of ways. So axial or front feed of axis. For the application of parabolic reflector, so first we have here the direct broadcast television. So this television or the parabolic antenna television has become a major form of distribution for television content. So the wide and controllable coverage areas available combined with the much larger bandwidth enables more channels to be broadcast, and this makes satellite television very attractive. The second one is the microwave links. Terrestrial microwave links are used for many applications. Often, they are used for terrestrial telecommunication infrastructure links. So one of the major areas where they are used these days is to provide the backhaul for mobile telecommunication system. Another one is the satellite communication. So many satellite uplinks or those for communication satellites require high level of gain to ensure the optimum signal condition, and that transmitted power from the ground does not affect other satellite in close angular proximity. So the ideal antenna for most application is the parabolic reflector antenna. And lastly, the last application of the parabolic antenna is the radio astronomy. So radio astronomy is an area where very high levels of gain and directivity are required. So accordingly, the parabolic reflector antenna is an ideal choice. So in all these applications, very high levels of gain are required to receive the incoming signals that are often at a very low level. For transmitting this type of RF antenna, design is able to concentrate the available radiated power into a narrow beam width, ensuring all the available power is radiated into the required direction. So those are the topics. So that's all of my report about the types of the antenna that I discussed earlier. So thank you for listening.